Okay, welcome back, Lab Partner. We're ready for reaction 2. Reaction 2. All right, we're doing this one right here. Got the data table transformed over here, and I've already taken the honor of putting the molarity, which we're using right there, 2 molar HCl. 2 molar HCl. We're using 15 milliliters. Already measured it out, 50 milliliters. And the initial temperature of the 50 milliliters of the sodium hydroxide, 2 molar sodium hydroxide. All right, we have to know that too, 2 molar. We're going the initial temperature, I've taken that already, and it's at 24.0. 24.0. Interesting, the water temperature was at 23.1 for the reaction 1. The sodium hydroxide is at 24. Why the difference, you might say? They've all been out in the room, right? Yeah, but the thing is, though, the water I got from the lab, which is actually a little bit of air conditioning, and back here there isn't any, so it's a little bit of a temperature difference. The sodium hydroxide, of course, has been in the lab prep areas where I am. All right, so that'll explain the difference. What I'm going to do now is we're going to take the hydrochloric acid, and we're going to pour that into our calorimeter. It's sitting right there waiting. I cleaned out the cup in the inside, cleaned it, washed it, dried it, and we also cleaned off the temperature probe, which we should be doing because you don't want to have residual sodium hydroxide sitting on there. We also can just kind of make a note of something here, that the acid, we can go ahead and use that in a glass container. The sodium hydroxide we use in plastic. Sodium hydroxide reaction will react. It's a slow reaction over time with glass, but not with plastic, so we always use plastic with our sodium hydroxide. All right, so I think we're ready. You can see here, I want to place the 15 milliliters in the styrofoam cup. Then we're going to place the sodium hydroxide in, and what we're going to do is just get a temperature change. So go ahead and place the sodium hydrochloric acid. This isn't easy, you know. Working with acids and bases. Back here myself, trying to video at the same time. Okay. All right. Now we're going to pour the sodium hydroxide in and get a temperature reading. So what I'm going to do is put you down. All right. Once again, I know it's going to be kind of boring for you, but I know it's so exciting. You do want to make sure that you're watching all the time. There's nothing better. Nothing better. All right, I got you. You're back. All right, we're mixing those together, getting a temperature right now. It's at 38 degrees. The first temperature, I just got sidetracked. I was going to tell you that in the first video. The first reaction is a solution, and it's called heat of solution. When the solution was being formed by the pellets which were dissolving, we got heat release, and this is a neutralization reaction. We have 2 molar, same amounts of each strong acid and a strong base. Hope you remember that, sodium hydroxide and hydrochloric acid. We ended up getting neutralization with those two. Now, theoretically, I could drink that. It should be just salt water in there. Do it, you won't. Do it, you won't. You're right, I won't. I trust his chemistry, but not enough. And besides, salt water is not going to be very yucky. And it's warm salt water. Look at that. We got a temperature of 38. I don't think we're going to change at this point. There's nothing to dissolve. They just mix together. And I think 38 is going to be calling it. Okay, so we're going to write that temperature down. It's not moving at all. We've got that nice and mixed at 38.0 degrees. So the final temperature of the mixture is 38.0 degrees. All right, that's reaction 2. Lab partner will react when it was set up.